Good morning, everyone. Welcome back to another exciting day in mathematics. Renzo. Warm-up 106 is on the screen. Let's get started, please. And you have handouts that you were given over here on the table. The warm-up is in there. I left you plenty of space underneath that and the fair model so you can do the work. Get started. Go. All right, here we go. So, not yours. Number one, by now you should have had your graph look like this and like this. Yes? All right, good. Number two, g of x, we first rewrite this and it should have written 1/3 f of x plus 4 squared plus 2. What does that mean? This compresses, this moves it to the left, this moves it up. Number three, a, this becomes 1/8 to the 5th. B, this becomes 1. C, this becomes x to the 4th over 1 or x to the 4th. 4, this becomes 2 to the x over 32. And this one is, let's see, the center is at 2, 1, and the radius 1. Hands if you got that. That is correct. Let's go. All right, the agenda for today, warm-up 106, rational functions, 6 graphs for rational functions for home plate. I put that at the bottom of that handout, so you already have it. Yes? You guys see it? All right. Copy this code, KQFHE. That's access to the home plate for tonight. KQFHE. And last night's home plate was this. It's a gift from me to you. Aww. Thank you, Mr. Q. You're welcome. All right. Tonight's home plate, though, look at that beautiful setup right there. Let's go. Only 6 of them. All right. So with that said, I can solve and graph rational functions. Write that somewhere on your handout. I can solve and graph rational functions. And basically today we're only going to focus on graphing. We're only going to focus on graphing. So I can solve and graph rational functions. So what are rational functions, everyone? Well, rational functions are an equation that contains one or more rational expression. And I gave you guys these examples. Check this out. Does this one have any, is it an equation? Yes. Does it have at least one rational expression there? Yes, there it is. This one is an equation. It's got 2 rationals. Same here. All right, write these non-examples down. 6 over g plus 4. Then we got on the right, we have x squared plus 3x plus 2. And then down here we have negative 3 plus x equals 10. All right. So before we move on, tell your neighbor why this one is not a rational function. Talk to your neighbor. Why is that one not a rational function? Why is that one not a rational function? Get off those phones. Let's see. Looks like Enrique's got this. But we're going with Joseph. Why is that one not a rational function? It's not being divided by something. That is correct. Is it an equation, though? Yes. But it doesn't have a rational or a fraction anywhere. All right, that is correct. And the other two, obviously, you should know why the other two are not rational functions. Pass on one, Joseph. Enrique, why are these not rational functions? They don't have an equal sign. They're not equations. That is correct. All right, so hashtag. What makes a rational function a rational function? Well, it has to be an equation and at least one rational expression, or in other words, at least one fraction. At least one fraction. All right, so steps that we're going to take today. Look up to the screen. We're going to identify the vertical and horizontal asymptote. We're going to build an input-output table, and we're going to graph the function. So turn your handout over to the back from where the warm-up was at. Write those 3 steps at the bottom of your paper, at the bottom. I'll give you some time. Go. All right, once again, steps. Identify vertical and horizontal asymptotes. Build an input-output table. And graph the function. Okay, I'm going to move on. You have the code to log in and get the slide in case you missed some of the processes. Here we go. Now, I'm pretty sure you're wondering, Mr. Q, what is an asymptote? What is that word? Well, let me elaborate. Before I get there, let me revisit our general rule. Look up. We started with a general transformation rule that looks like this. Now, by now, we should know that K does what? Tell your neighbor. K does what to the function? Tell your neighbor. Kelly, what does K do to the function? Up and down, that is correct. What does H do to the function? Kelly, pass someone. Mariah. Yeah, left or right. Side to side, that is correct. What does A do to the function, everyone? It either stretches or compresses. Stretches or compresses, but vertically. Once again, you don't have to copy this. You already have this. So what does B do to the entire function, Mr. Q? Same thing, stretches and compresses, but horizontally, which is like that. All right. Well, guess what? Today we're tweaking this now to meet the function that I'm introducing today. Here it goes. Y'all ready? Look how beautiful this next one looks. First of all, do you guys notice that it has all the same parameters as the general rule? Yes. So, does it have a K? Yes. Does it have an H? Yes. Does it have an A? Does it have a B? Yes. What is the only thing you guys notice on that new one? That it has a what? A 1 on the numerator for all this inside of the parentheses. Therefore, it brings me to what we're going to cover today. Asymptotes. Here he goes. Write your utensils down. You don't need to copy this. It says an asymptote is a line that a graph gets closer to as the value, absolute value of the variable increases. Now notice it says gets closer to. That means it never crosses it. It only gets closer to. So what does that mean? In my words, I said, in other words, it's an invisible line that a graph will get close to but will never touch. Kind of like, have you guys watched Star Wars movies, right? That there's a force field around stuff and sometimes you can't penetrate that. It's invisible. It's like an invisible force field. There's 3 types. There's vertical, there's horizontal, and there's diagonal, slant, or oblique. For today, we're going to focus on vertical asymptote, which means it's an invisible line that goes like that. Horizontal, an invisible line that goes like that. And then the other ones, we'll get there when we get there. But for right now, we're just going to focus on those 2. So with that said, all right, so you're still in the back, is that correct? Next to the steps that you wrote, I want you to write this form, please. g of x equals a times f, parentheses, 1 over b times, times x minus h, close parentheses, plus k. So whenever I give you a function that looks something like that, from now on, the h is our vertical asymptote, and our k is our horizontal asymptote. Our h is vertical, our k is horizontal. Once again, the h is going to give us a vertical invisible line, and the k is going to give us a horizontal invisible line, like so. Okay, we got it? All right. So with that said, go to the front side of that handout, please. Bless you. Here we go. Start with example 1Q, this one, the parent function. I've been giving you this one already from the beginning, from the get-go. So first thing I want you to write next to it, I want you to write VA, which stands for vertical asymptote. And then you're going to write X equal. So look up, look at my fraction, and look at our general rule. Question, is there anything next to the X here? No, so therefore my vertical asymptote is 0. Next, I'm going to write HA, horizontal asymptote. And I'll write f of x Question, is there any k at the end of that fraction? Is there any constant? No, so my asymptote is 0. So how does that look over here? So let's graph it over here. Check this out. In blue, I'm going to graph the vertical asymptote. So here's 0 of x. Vertical, I'm going to do a dotted line to indicate that there's an invisible line going through 0 of x. That's my VA. Next, f of x equals 0. So f of x is our y, and that's a horizontal invisible line. And I'm going to do that in red. All right, how we doing? Good? All right, let's go to the next one, example super Q. I want you to write VA. Oh, change the font on that one. VA x equals. So now check this out. Whenever you have this on the denominator, to find the VA, set it equal to 0 and solve. Plus 1 plus 1, x equals 1, so my VA is 1. HA, which is our f of x. Question, our f of x is, or our horizontal asymptote is our constant. What is my constant here, everyone? 2. So if I was to ask you to graph this, let's see, my vertical asymptote is at x sub at 1. Here it is. And my horizontal asymptote is at 2 of y. There it is. How are we doing? Good? All right, let's do the third one. Here we go. I want you to label this one VA x equals. How do I find my VA for this one, everyone? Set the denominator equal to 0 plus 3 plus 3. 2x equals 3. Divide by 2. X equals 1.5. That's my VA. Tell your neighbor what the HA is. F of x is what? What is our HA? All right, what's our HA, Caesar? 5. That is correct. All right, let's graph that. My VA is at 1.5 of x, which is here. Do a vertical line. Invisible line going through 1.5. And our HA is at 5 of y. There it is. From 1 to 5, I'll come through. Are you finding the vertical and horizontal asymptote? 5, 5, 5. Okay. So, go to the next ones to the right. A, B, and C. I want you to find me the VA and HA for each of those and graph them on your paper, please. I'll give you some time. Go. All right. Okay, for 1A, I need a VA, x equals, and an HA, f of x equals. Let's go with Sebastian. What'd you get, Sebastian? VA is 3, and 8, and the HA, 2. So, VA is at 3. And HA is at 2. Hands if you got that. All right. Go to B. I need a VA and an HA. Pass someone, Sebastian. Hey, bro. What'd you get? -3 and 4. So, -3 is over here. +4 is right there. Hands if you got that. All right. And last but not least, VA and HA. Pass them on, Gabriel. -7 and -5. -7 is over here. And -5 over here. And if you got that, from 1 to 5, I'll come through. Are you identifying the vertical and horizontal asymptote? Yeah, 5. Now, let me give you an observation. Look up. Even though I told you the denominator, you set it equal to 0 to find the VA, there's a faster way. Look up. Just by observation. Look at the denominator. Look at the VA. Look at this denominator. And look at the VA. Let me go to the previous ones. Look at the denominator. Look at the VA. And of course, that only works when there's no coefficient on the x. Tell your neighbor what you notice. What do you guys notice? What do you notice for the VA? All right. What do you notice, Geo? Yeah, the opposite of what you see there is our VA. All right. So, now that we got that down, let's go to the best part. Turn your paper over. Let's go. Example number 2, graph the function. According to the steps that I gave you, it says identify the vertical and horizontal asymptotes. So, first we write VA, x equals, HA, f of x equals. Oh, I went faster than my brain, okay? So what is our VA, everyone? Does it have any number next to the x? No, so it's a 0. And do we have a constant at the end? No, there's no constant, so it's 0. All right, so let's graph those really quick. X is right here, and it's our VA, so it's going up and down. And then our HA at Y0, and then we go sideways. There's our invisible lines. So those are our asymptotes, which means our graph cannot touch those lines. Are we there so far? Next, we need to graph our function. So pay attention to this part. Write your utensils down, look up to the screen. Whenever you get to this part, I want you to choose 2x values on the left side of the vertical asymptote and 2 on the right side of the vertical asymptote. Well, first, where's the asymptote? Where's our vertical asymptote? Right here. So, tell your neighbor what 2 numbers I'm going to choose on the left and what 2 numbers I'm going to choose on the right. What 2 numbers? Yeah, so from the left, I'm going to choose what? -1 and -2, and from the right, I'm going to choose 1 and 2. So I'm going to use that for my table. So x, f of x, -2, -1. Now, I am going to leave the space for 0 because I'm going to show you, I'm just going to make sure I show you what we see, 1 and 2. All right, so if I substitute -2 in here, what does that give me? Tell your neighbor. Yeah, we've been doing this on the warm-ups, yeah? It gives me -1/2. If I substitute -1 in here, what does that give me? -1. If I substitute 1 in there, it gives me 1. If I substitute 2 in there, it gives me 1/2. So, let's graph that. Here we go. I'm going to use green to graph. -2 1/2, -2 1/2, and -1 -1. Connect them with a little curve to it. And then an arrow like so, and an arrow like so, indicating that you're getting closer to the asymptotes, but you're not touching the asymptotes. Go to the top. 1 1. 2 1/2. Same thing. Curve it, arrow, and arrow. And there you go. Rational function students, rational function. So what do you guys notice? That the 0 is an asymptote. That's why this is called undefined. Undefined because it never touches. From 1 to 5, how comfortable are you graphing so far? 5 4, 5 4. Yeah, we did a lot of practice on the warm-up. Let's do another one. Example 2 super cube. You have it right there next to the other one, yes? So step 1, identify the HA and the VA. I'm sorry, the VA and HA. So. VA, HA. All right, tell your neighbor what the VA and HA are from here. All right, Enrique? VA, 1, HA, HA. Two. All right, let's graph those. X equals 1. And Y equals 2. By. All right, next. Here's my VA. Tell your neighbor what two numbers I'm using from the left and what two numbers from the right for our table. What two numbers from the left and what two from the right. Oh, and it's no longer f of x, it's g of x. Did you get past someone? Who? Joseph, what two numbers from the left, what two numbers from the right? Okay, let's see. Here's the invisible line. What two numbers are to the left? -1 and 0, okay. -1 and 0. And what two numbers to the right of the invisible line? Are you sure? Okay, here's my invisible line. We're looking at the x values. What two numbers to the right of that line do you see immediately? Yeah, 2 and 3. Okay. Yeah, I just wanted to make sure because you're looking like a little insecure. So 2 and 3. And what is our asymptote, everyone? 1. And what are we going to write for 1? Undefined. All right, so let's fill our values. So I'm going to write this, look up this function, 1 over parentheses -1 plus 2 So let's substitute our first value. Our first value is -1. So we end up with, let's see, 1 over, -1 and -1 is -2 plus 2. So what is 2 plus -1/2, everyone? 2 minus 1/2 is 1.5? Yeah, 1.5. Let's do it again. 1 over blank minus 1 plus 2. My next value is 0. So that gives us 0 minus 1 is -1. So it's 1 over -1 plus 2. What is 1 divided by -1? Thinking caps. 1 divided by -1. Renzo. So 2 minus 1 is? 1. Okay. Continue. What is my next value, everyone? The next value is 2. So we end up with 1 over 2 minus 1 is 1 plus 2. What is 1 divided by 1? 1 plus 2, that is 3. And the last one, we're going to substitute the value of 3. So 3 minus 1 is 2, so we end up with 1 over 2 plus 2. So what is 2 plus 1/2? That's 2.5. All right, let's graph those. Negative 1 and 1.5 y. Negative 1, 1.5 is about right there. That was this one. Let's go to the next one, 0 and 1, 0 and 1, 0 and 1. So there we can graph our little curve with our arrows. Then undefined, let's go to 2, 3, 2, 3, 2, 3 is right here, which is that one. And then 3, 2.5, 3, 2 and 1/2. And there you go. How are we doing with the process from 1 to 5? How comfortable are you up to right there? 4, 5, 4, 5. Okay. Once again, here goes the process one more time. Step 1, you got your VA and HA. We graph those. Step 2, build the table by choosing 2 values to the left of that vertical asymptote. And I chose, Joseph chose the 0 and the negative 1, and to the right of the vertical asymptote, he chose 2 and 3. And of course, this is 1. That's why we wrote what? Undefined, because we don't cross that invisible line. All right, so I did one with you guys. Here goes another one. Do that one by yourself, please. It says graph the function 1 over x plus 2 minus 3. Go through the entire process. I'll give you guys some time. And go. All right, take your work so far. Look up to the screen. And so you got for the VA and the HA. Okay. Look at the table. I chose 2 values to the left. That means negative 4, negative 3. 2 to the right, negative 1 and 0. My undefined is negative 2. So let me graph that. Negative 4, negative 3.5. Negative 4, negative 3.5. Negative 3 and negative 4. Negative 3, negative 4. Now I'm going to the right side of the asymptote. Negative 2, negative 1. Negative 2, negative 1. I'm sorry, negative 1, negative 2, sorry. Negative 1, negative 2. And 0, negative 2.5. 0, negative 2.5. There you go. One to 5, how comfortable are you with that so far? Yeah, 5 4s, 5 4s. We got this, yes? Once again, the process. Identify HA, VA, VA, HA, graph those. Select 2 values. Once again, let me remind you, here's the vertical asymptote. You select 2 x values from the left, 2 from the right, and those are the ones that we use here for our domain, our x. And of course, where the asymptote goes through, which is negative 2, is our undefined. All right? So, look at this one, example 2 mega cube. VA, X equals HA. F of X equals. All right, tell you never the VA is on that one and the HA. VA and HA. VA and HA. What'd you get for that one? Let's go with Elijah. What'd you get? 2 for the VA. And for the HA? -3, and the rest is history. Yes? We got it? All right, so I'm going to go ahead and stop right there. Once again, reminder on the home play, you wrote down the code. However, there is a home play again on the screen on YouTube in case Nearpod gives you a hard time. Those of you following on YouTube, put some practice in. See you guys next time. Peace.